Welcome, ladies and gentlemen, to section 4.5, dividing polynomials. We're going to start with dividing a polynomial by a monomial. In this video, in part 2, we're going to get into a little tougher, dividing a polynomial by a polynomial. So if you're interested in that and you understand this process, that's fine. Skip ahead to part 2, but this is going to be the introduction. So dividing a polynomial by a monomial. First, we're going to start off with the generic case, a plus b over c. This can be rewritten as, let me change the colors for emphasis, we have a over c plus b over c. Okay, just like, oh, and c can't be equal to 0. The reason why it can't be equal to 0 is because you can't divide by 0. It's undefined. The reason why this works is if we have the number 2, 1 over 2, sorry, plus, let's call it 3 over 2. This becomes 4 over 2 or just 2. Now, this is the same thing as combining 1 plus 3 over 2. Okay, so that's what we see here, a plus b over c. As long as the denominator is the same, we can combine those two fractions together. Now, why is this useful? To be able to split up fractions from this to that. Well, it makes it easier to simplify expressions like this. Now, this can be rewritten as 15x squared over 3, because all of these have the denominator of 3. There's addition and subtraction at the top, and so we can split it up. So you have 15x squared over 3 minus, then we have 12x over 3 plus 3 over 3. The denominator is the same each time, so that's valid. And now we're ready to just simplify each expression. We already knew that we couldn't combine these terms in the top because they're unlike terms. Okay? So that's the first thing we recognize. So the second thing is we can reduce each one individually, each expression individually. So we do 15 divided by 3, and that gives us 5x squared. Okay? What we did there is essentially cancel. That's how I like to think of it. Minus, we have 12 goes into 3 4 times, we get 4x, and then 3 divided by 3 is just 1. So this expression reduces to 5x squared minus 4x plus 1. A simpler way to do this, and this is the way I prefer, is to simply just look up here and realize that this 3 can be divided into each one of these terms in the top separated by addition and subtraction. So I can do 15 divided by 3 here, cancel with that 3, 12 divided by 3, cancel with that one, and then this 3 cancels to give me 1. So I get 5x squared minus 4x plus 1, and that's what I got here. You have to be careful using that method, though, because if it's not divisible, you're going to see that you're going to have to leave it in a fraction. Okay, and hopefully we'll get to an example later on with that. So the next one I have is 5m cubed minus 9m squared plus 10m. Again, I can rewrite this as 5m cubed, just so you guys can see it. I like canceling without rewriting it, but just so you guys can see it, 5m squared plus 10m over 5m squared. So this is a good one. Remember how I said that we're going to have some that remain as a fraction because you can't cancel? That's what's going to happen here. Not the case with the first term, as we have 5m cubed divided by 5m squared. What happens is the 5's cancel. 5 divided by 5 is 1. And with multiplication, 1 is the identity principle. So we have 5 cubed over 5 squared. Some people like to subtract the exponents to get m to the first power. I like to just cancel 2 in the bottom with 2 in the top, leaving me m to the first power, or just m. Next one, the m squareds cancel completely. M squared divided by m squared is just 1. But here's the thing I was talking about. The 9 and the 5 cannot cancel completely. So we're just left with 9 over 5. There's no m. Okay, moving on to the next one. We have 10 in the 5 cancels, and we're leaving 2 in the top. 10 divided by 5 is 2, leaving me 2 plus 2. This m cancels with one of the m's in the bottom, so it remains 2 over m. That m stays. So this is our new expression that we have m minus 9 over 5 plus 2 over m. So you can see that it doesn't always cancel nice and neat like it does here. Sometimes you're still left with fractions. So if you take a look at this first one here, we see that Sorry, I knew I was sneezing. Tried to avoid it. Well, we're live, but we're going to roll right through it. If you're trying to divide this among all three terms, like I showed on the top, you can do that. What happens is, as we just showed, you cancel, and we're just left with an m in the top. Okay, that gets canceled, but you have to do this 3 times. So now I have to do it with the middle one. The 5 does not cancel, but the m's do completely. So we're left with that 9 over 5 in the middle term. And then the last one, we see that with the 10 cancels with the 5, leaving us 2. The m cancels, leaving us with just the m in the bottom. So it's a little mess here. And if you do it one step at a time, kind of like going over to this over here, it works. If you want to rewrite it and then go from there, that works, okay? It's up to you. This is probably the safest way to go. This is probably the most efficient way to go, but you have to be careful. I would build up from this into this method right here, okay? I have way too many arrows. Let's get rid of some. Okay, so then this was our final answer. Okay, I'm going to show first my method and see if you guys like it, and then you guys can rewrite it if you want, but I'm going to try to keep this video short. Okay, we're going to divide this 3 times. So we're dividing this one by this one first. Then we're going to do this one second, the middle term second. Okay, and then I'm showing that we're dividing each time. And then we have this one third. Oops, I don't like it when it overlaps like that. There we go. Okay, so we divide it 3 times. Let's start with the yellow or gold, whatever color that is. We have no coefficient in the bottom, so the 8's just going to stay. And then we have an x in the top is going to cancel out with one of the x's in the bottom. So we're going to have a fraction here. And there's going to be an x in the bottom, okay, because this is in the bottom already. The y squareds are going to cancel completely, so we're left with just 8 over x. That's the first one. Moving on to the blue, the middle. Okay, minus. We're going to keep the sign the same because there's no minus in the bottom to cancel out. Minus. The 9 stays in the top. There's no coefficients to reduce. The x squared. So this x cancels. This x squared cancels with both those x squareds in the bottom. So the x squared's gone. This y only cancels with one of the y's in the bottom, so now we have a y in the bottom in the middle term. Done with the middle one. Now we're moving on to the green. Again, plus, there's no other sign. 6, there's no other coefficient. The x squareds are going to cancel. Boom, x squareds are gone. Whoops, didn't mean to scroll up. Boom, the y squareds are gone. They cancel. So it's just 6. Okay, it was just a 6. And that's it. That's all there is to it. This is the reduced form of that. Now, if you want to rewrite this whole thing and make it 8x y squared over x squared y squared minus 9x squared y over x squared y squared plus 6x squared y squared over x squared y squared, that's fine. And you're going to see that each one is going to reduce just as we described here. So I'm not sure which you prefer. If you cannot keep it straight in your head as you do it, that's fine. I would rewrite it like this, but this is the way that we do it. That concludes part 1 of this video. Join us next time as we talk about dividing a polynomial by a polynomial in part 2. Can't wait to see you there.